Hello, students. It's JD here. Today we're going to quickly resume from where we left last time. Remember, we are still busy revising the question paper that was written in May, June 2022. And this is A-level mathematics syllabus 9709. Currently, we are doing part 3. So let's take a closer look at question number 6. Question number 6, it reads, the variables x and y satisfy the differential equation. In this syllabus for A-level 9709, the only differential equations that we do are first order differential equations which are separable. So we're not going to do second order or even first order that are not separable. So we know that this is the first order differential equation and it is separable differential equation. What do we mean when we say it's a separable differential equation? A separable differential equation should be of the form, let's say maybe you might have a function in terms of y being multiplied by dy. And also on the other side, maybe you might have a function of x, maybe being multiplied by x. So let's say you've got g of y with respect to y and f of x with respect to x. Then you know that the function is separable. So if we have this differential equation, dy dx is equivalent to x times e to the power of y minus x, we need to make sure that we rewrite this function until we have a differential equation of this form, whereby we've got the function in terms of y with a dy and the function in terms of x with a dx. Okay, so we have dy dx is equivalent to x times e to the power of y minus x. This is a very interesting problem. So what are we going to do next? So the next thing that we're going to do, let's keep our dy dx here, and let's write this as x times what is e to the power of y minus x. So if we reverse exponent, we can see that, remember, if you have got e to the power of y divided by e to the power of x, remember from what we've covered back then in primary school that when you are multiplying powers with the same base, right, you keep the base and you add the exponent. You subtract the exponent, sorry. So when you are multiplying, that's when you add the exponent. If we say e to the power of y times e to the power of x, that's when we keep the base and we multiply the exponent. But when we are dividing powers with the same base, you simply keep that base and you subtract the exponent. So e to the power of y minus x, yes, it is the same as e to the power of y divided by e to the power of x. So here, instead of me writing e to the power of my y minus x, I can write this as e to the power of y divided by e to the power of x. So what are we going to do next? Now let's start to separate the variables. Let's make sure that on the other side, we put a function in terms of y being multiplied by dy, but make sure that dy is on the numerator. Another side, you must have a function of x being multiplied by dx, but make sure that dx is also on the numerator. So how are we going to do it here? So let's multiply both sides by dx. So what are we going to do here? Let's multiply both sides, right, by dx. So if we multiply both sides by dx, we are going to see that we're going to have dy is equivalent to x divided by e to the power of x times e to the power of y times dx. Right, we've multiplied both sides by dx. So as you see here on the right-hand side, we have x over e to the power of x times e to the power of y. So let's get rid of this e to the power of y, so that this function of y will also be on the other side. So let's divide. Both sides. Let's divide both sides by e to the power of y. So if we divide both sides by e to the power of y, what are we going to get? We are going to get dy divided by e to the power of y is equivalent to x divided by e to the power of x dx. This is quite interesting. what are we going to do next? What are we going to do next? So as you see here, this is basically the same as e to the power of minus y. Y is equivalent to x times e to the power of minus x dx. As you see here, we have arrived at the point whereby on the left-hand side, we've got a function in terms of y being multiplied by dy. On the other side, we also have a function in terms of x being multiplied by dx. So we have successfully managed to separate the variables. Okay, so what are we going to do next? So the next thing that we have to do, we have to integrate both sides. What are we doing here? We are integrating both sides. So integrate both sides. So we have to integrate both sides. What do we get if we integrate both sides? So let's consider each and every side. So consider the integral on the left hand side. Consider the integral on the left hand side. So the integral is the power of minus y dy. How do we integrate exponential function? How do we integrate exponential function? So for us to integrate exponential function, let's say, for example, we are looking for the integral of e to the power of f of x with respect to x. How do we integrate this? So what we have to do is differentiate the power, right? Once you have the derivative of the power, divide by that derivative, and then multiply again by e to the power of f of x plus the constant of integration. So if we use this concept here, we can see that we can also differentiate minus y, so we get minus 1. So let's say 1 over minus 1. Then we write again e to the power of minus y, right? Plus a constant of integration. So by the end of the day, if we simplify this much better, you can see that the result is still minus e to the power of minus y plus the constant of integration. So yes, that's the answer that we get if we integrate the left hand side. Let's also consider the right hand side. The right hand side is the integral of x times e to the power of minus x dx. Oh my God, this is quite interesting. We want to integrate the product of two functions. We have got the function, the polynomial function x being multiplied here with an exponential function which is e to the power of minus x. So how are we going to tackle this problem? So to tackle this problem, this is very interesting. Use integration by parts. Use integration by parts. So whenever you're trying to integrate the product of two functions, use integration by parts. Integration by parts. How do we use integration by parts? So we have to let one function to be u and another function to be dv dx. So here we're going to let u to be x, and we are going to let dv dx to be e to the power of minus x. So from the one that we have let it to be u, we have to find dv dx, and straight away dv dx is 1. Right, for the one that we have related to the dv dx, we have to multiply both sides by dx, we get that dv is equivalent to e to the power of minus x dx. And the next thing, we have to integrate both sides. If you integrate both sides, you're going to see that d is equivalent to minus e to the power of minus x plus the constant of integration. Okay, so now we have the value of du dx, the value of u, the value of dv dx, and the value of v. We have to go and plug into our formula. Check your formula booklet. It's given that the integral of v, the integral of v du, the integral of integral of u dvx is basically equivalent to uv minus the integral of v times du dx. So if we substitute, you can see that what value that we have related to du is basically x, and which value we let it v dx is basically e to the power of minus x. So here we are integrating with respect to x. With respect to x, it's equivalent to what is our u value? It's x, and what is our v value? It's minus e to the power of minus x minus the integral of what is the value of v minus e to the power of minus x, and what is u dx is 1 by dx. So yes, that's how we integrate using integration. But parts, then the next thing, let's simplify, we get minus x e to the power of minus x minus, if we integrate this, we're going to get positive e to the power of minus x plus a constant of integration. What is happening here? Remember the integral of e to the power of minus e to the power of minus x. So if we try to find that integral, by the end of the day, minus e to the power of minus x, when the derivative of minus x is minus 1, we are dividing by minus 1. That this whole thing turns out to be positive. So yes, this is the result that we get. Wow, this is quite interesting. But we still have a long way to go. This is the result for the right hand side. So now we need to combine the results. Remember, we know that the left hand side we said is equivalent to the right hand side. And we worked out the left hand side. On the left hand side, we have seen that the integral of e to the power of minus y with respect to y, we got minus e to the power of minus y plus a constant of integration. So it's minus e to the power of minus y. No need for us to put that plus constant of integration because we're still going to put it on the other side as well. So we need only one constant of integration. So it's equivalent to which result that we get when we simplify the right hand side. We got minus x e to the power of minus x minus e to the power of minus x plus the constant of integration. This is what we get upon integrating both sides. So let's go back and see if we've got further information, because the result that we have here right now, we call it the general solution. We call this the general solution. So let's try to get back and see the initial conditions that are provided. Given that when y is 0, x is also equal to 0. So these initial values will help us to find the value of c. So in this case, when y is equivalent to 0, x is equal to 0. So if you plug in the initial values of y and the initial values of x, we'll be able to find the value of c. And once we get the value of c, we then rewrite again the solution, replacing c with that value that we are going to calculate. And the final answer will be our particular solution. So in this case, minus e to the power of minus 0 is equivalent to minus 0 times e to the power of minus 0 minus e to the power of minus 0 plus c. So obviously, e to the power of 0 is going to get us 1. So here we get minus 1 is equivalent to, but 0 times this, we are going to get 0. Minus e to the power of 0, we're also going to get minus 1 plus c. So therefore, our c is equal to 0. So if our c is equal to 0, then we can rewrite now that general solution, replacing that value of c. So the final answer now will be minus e to the power of minus y is equivalent to minus x times e to the power of minus x minus e to the power of minus x plus 0. No need for us to write because the solution is just 0. We say plus 0 and not writing is the same thing. So yes, this is our solution. But let's go back again to see the standard technique we have to leave our answer. They say solve the differential equation, obtaining an expression for y in terms of x. So we still have to make y the subject of the formula. How are we going to make y the subject of the formula in this case? So we have e to the minus e to the power of minus y is equivalent to minus x and e to the power of minus x minus e to the power of minus x. So let's divide each and every term by minus 1. So if you do that, we're going to get e to the power of minus y is equivalent to positive x times e to the power of minus x plus e to the power of minus x, because we divided each and every term with a negative result. And then the next thing, let's take natural logarithm both sides. Take ln both sides. So if we introduce natural logarithm both sides, we've got ln of e to the power of minus y is equivalent to ln of x times e to the power of minus x plus e to the power of minus x. So ln of e to the power of minus y gives us minus y, right? Remember, ln of e to the power of f of x. If you say ln of e to the power of anything, the answer that you get is that power. Okay, so minus y is equivalent to ln of x times e to the power of minus x plus e to the power of minus x. Right, remember we want to make y the subject of the formula. So far the question of y is minus 1. So let's get rid of that minus 1 so that you can remain with y alone. So divide both sides by negative 1. And this is going to give us y is equivalent to negative ln of x times e to the power of minus x plus e to the power of minus x. So yes, this is our final solution. This is the final solution. We've managed to write y in terms of x. This is very, very interesting. So as you see this question, there are 7 marks for this question. How are these marks going to be awarded? There are 7 marks. So the very first thing is you see a differential equation at advanced level, right here in your mind. What you have to do, firstly, you have to separate the variable. It's very important for you to separate the variable. And then after separating the variables, you have to integrate both sides. Integrate the left-hand side, integrate the right-hand side, and also integrate the left-hand side, and also integrate the right-hand side. In this question, it was very interesting because in an attempt to integrate the right-hand side, you realize that the function that we wanted to integrate was a product of 2 functions. And we have to use integration by parts. That was very, very interesting. And then after doing everything, we got what you call general solution. So once getting that general solution, there were initially conditions that will provide that when x is 0, y is 0, that helps us to find the constant of integration and arrive at the particular solution. And after arriving at that particular solution, to comply with what they wanted here, they say obtain an expression for y in terms of x. So yes, we have the particular solution, but y was not the subject of the formula in that case. So if we make y the subject of the formula, we then arrive at the solution. And yes, we then deserve to get all 7 marks. Yeah, this was very, very interesting. Awesome.